Hi, welcome back.
Hi.
So I realized after we had a partial solution to Advent of Code day 12. Oh yes, by the way, this is Dad and Kids Coding, working on Advent of Code 2020. I realized when we had were working on day 12 yesterday, and we were working through the first part, and it went pretty well. But I realized that I was actually not um, doing what I strongly support, which is test-driven design. We have been writing tests before we write the code, but the tests have been pretty minimal, and we haven't really been testing the details. And this problem became a little bit clearer that it would be advantageous to be doing it more deliberately. So I'm going to throw away the code that I had yesterday and redo the code for this problem. And I think it's going to be a lot easier to understand, and we'll also get, I think we'll be able to transition to part 2 much more easily. So that said, let's go over to the code. And day 12A, I'm going to throw away most of this code. In fact, I'm going to throw away pretty much all of this code. I'm going to create a new data type. So the way I've been coding, or we've been coding up to this point, has been really, you could have been coding in pretty much any language. We haven't been using Smalltalk, but we haven't really been doing it in the sort of incremental way that is more Smalltalk. So I'm going to create a new class here, and so I'm going to say np to be, I'm going to call it nav position. And create a new instance of that. And then I'm going to loop through the lines, and I'm just going to say np command line. So I'm going to make that so it understands line. And then here I'm just going to tell it to return the np Manhattan distance. So I'll just call it Manhattan. I don't call it Manhattan distance.
Oh, I'm pretty sure Manhattan isn't. Oh, whatever.
Well, let's just go over because it happens to have Manhattan down here somewhere. So let's see.
There it is.
Manhattan.
Oh, you're correct.
So that's going to be our day 12B, and our day. Oh, I meant to do day 12A. We're going to replace day 12B too, but so day 12A is going to look like this. And I have nav position, which is going to be a new class, and that's perfectly fine for that class. Okay, so now we're ready to proceed. Except I've created this new class. I think I should probably actually have tests for nav position. So I'm going to create a new test where I'm just going to exploit the, so I'm going to call this test. Oops, just go here, put a test over in the test side. So copy this over here. And so test day 12A and B look like this, but I'm going to create a new test that's not a day test, but a nav position test. Okay, and then I'm going to self-assert, well, I'm going to create an instance of a nav position, and then I'm going to give it some commands. So if we go over here, they had some pretty good help. So here we have F10 would move the ship 10 units east, and we would then be in east 10, north 0. So let's just do that. So let's say np command F10 and then after that we should assert that the np north equals, and this said north should be 0 and east should be 10. So equals 0 and self assert np east equals 10. Typing too fast. 10. Okay, so let's just save that and then start to run it and see what happens. So run our test, and not surprisingly we get that we didn't understand command, so let's create that. And so we'll go to put this in that position, and we've got an F10. Well, we know that all of them are going to have a number, so let's set a number is a string all but first as number. Okay, so we have a number, and then let's just be fairly straightforward about this, and let's say if a string first is equal to an F, if that's true, I'm typing too fast, if that's true, then what do we want to do? We want to tell it to we want self move, or call it move forward maybe. Move forward and number. Okay. So that's pretty straightforward. Of course, we don't have a move forward method, but let's just do that in a moment. So we'll save that and tell it to proceed. And of course, we don't have a move forward, so let's add move forward. And what do we want to do here? So we want to, depending upon what direction we're in, we want to move east or west. So let's say that we have an orientation, and let's just so let's say let's say move will be, so if we have something called orientation, so the orientation is going to tell us whether we're pointing north, east, south, or west. Okay, and I'm going to do them in that order, which is different than I did before, but I think it makes more sense. So if the orientation is greater than 2, then I'm going to keep track of how far north I am and how far east I am. So if orientation is more than 2, then it means it's west or south, which are going to be negative values. So if that's true, then I'm going to want an integer negated. And if false, I'm going to want an integer. Okay, So that's going to be the amount, whether we're going to move up or down or left or right. So the negatives will be for west. So negative east is west and negative north is south. Okay, so that's that. And then I want to say, is the orientation mod 2? So this tells me whether it's north-south or east-west. So if this is equal to 1, then that means it's 1 or 3, which are north and south. So if it's 1, if that's true, then I will want to say self move north by move. And if it's false, then I want to move east. Self move east by the move amount. Okay, so I'm always going to move north, possibly a negative amount, or east, possibly a negative amount. So let's save this. So orientation we want to be an instance variable, and move we want to be a temporary variable. Okay, so that's fine, but we didn't initialize orientation, so I'm going to quit from this and go back and edit my nav position class, and I'm going to add an initialize. And it's going to super initialize, and then we'll set orientation to east, which is 2, east. And then also I'm going to have a north and an east variable, and we start off at 0. Okay, so I think that's east would be an instance variable and north would be an instance variable. Okay, so now let's go back to our test and try running it again and see what happens. Okay, so everything worked fine. We're actually trying to do a move east, which makes sense because we haven't turned at all yet. So we'll create this in that position, and we'll just say east is east plus an integer. Okay, and proceed. And we have asking for north. We don't have one, so let's say create in that position. And it saw there was an instance variable there, so it figured, oh, you want to use the instance variable, which is what I do want. So proceed, east, again, create in nav position. Again, it sees one, so that's what I want. And so my test worked now. Okay, so let's go back to the example code, and it says now if we do N3, would move the ship 3 units north, and then F7. We'll just combine these two. We don't have to replicate every single line of this description. So let's just add here, copy these, and then we'll say np, oops, what? np command north 3, and then command what are we supposed to do then? An F7. Okay. Okay, and following that, oops, that didn't do what I wanted. Okay, so after that, north should equal 3 and east should equal 17. So 3 and 17. Save and run. And we got 0 instead of 3. Why is that? Well, because we had this command, except it didn't actually catch anything because there wasn't, it didn't, so basically it doesn't have enough stuff in it. So let's just restart and proceed into it. Oops, yeah, didn't mean to do that. Restart, step over the new, step into the command. So here probably what we want to do is at the end, let's do a self halt or self error. I do not understand and then a string. So if we proceed now, we get an error saying I don't understand a string. And that's because a string is, oh, so I meant to say return here. So return this. Okay, proceed again. Okay, so now, oh, it's because I've restarted it, and so it did things multiple times. So let's just rerun the test from the beginning. Okay, it says I don't understand N3. Okay, so what we should do is say if string first is a n, if true, return self move north number. And we may as well fill in the other 3. So if it's south, then we'll move north, number negated. And then if it's east,
then surely it'd be better to call it move vertical.
well, except that our variable is called north, so
okay.
But otherwise, yes, that would be a better name. And this would be west. We can move east. Number negated. Now, the reason that move north is in red is because we haven't actually had any move norths yet. We've had move east, so we're good. So save that and proceed. And of course, we're going to block on move north, create a nav position, and this is just going to say north is north plus an integer. Save that and proceed. Okay, so that passed. So that's good. Let's just, so the next thing we have to do is we have to do a rotate, or turn right 90 degrees. Okay, and then an F11. So let's put those in. So right 90, and then F11. And at that point, we should be at east 17, south 8. So that's east 17, and this should be minus 8, because we're south 8 rather than north 8. Okay, and then finally, we should just verify that self assert NP Manhattan distance equals What is it supposed to be? It's supposed to be 25. It's 25. Okay, so we've got tests for every single step of the way. We didn't test here left as well as right, but let's go and let's just run this and see where we get to. Okay, so we got I don't understand. That's because this is an R90 and we don't have an R. So let's just copy these two lines because they're going to be very similar. So if it's a right, then let's call turn right. Or rotate, let's call it rotate right. Okay, the number, and if it's an L, then we'll rotate right, the number negated. Okay, so let's save that and proceed. And now we get to, there's no rotate right, so we'll create that in that position. Now, we have two possibilities here. So the integer should be a multiple of 90. So let's just verify. So if an integer mod 90 is not equal to 0, then we should, if that's true, then we should return an error, self-error. Only turn multiples of 90. Okay, just in case something else shows up, because the code that I'm writing isn't going to handle that. And otherwise, we're going to rotate the orientation. So the orientation is going to be the orientation -1. So what we're doing is we want to add the integer divided by 90. So let's just add that in here. An integer divided by 90. And this is going to be a positive or negative number. And we want to add it to orientation, but we want it to stay within the range 1 to 4. So we're going to subtract 1 from the orientation. And then we're going to add this, add this mod 4. And then we want to take the whole thing. So this could be more than 4 or less than 1. So we want to do that whole thing and take it mod 4 and then add the 1 back. So this makes it relative to 0. Then we do our addition, take it mod 4, which is going to give us a number between 0 and 3, and then we add 1 back on to bring it back up to the right place. So let's see how this works. And it worked fine up to asking for the Manhattan distance. The Manhattan distance is going to be simple enough to do. And all we should do is return self north. Actually, just, abs plus self east abs. And proceed. Okay, so it worked. Red is just because there was an error partway along. So now let's go back to 12a and see if it works. So this was yesterday we found out that this was the correct number for day 1. Okay, so that all worked. So that's good. We've got it working for day 1. So now let's go and look at day 2, or part 2. So part 2 says, the instructions were a little bit ambiguous. What we were supposed to do was the actions indicate how to move a waypoint, which is relative to the ship's position. So this means move the waypoint north, we use the waypoint south, move waypoint, waypoint, waypoint. And L and R mean to do a weird thing. They rotate the waypoint around the ship left counterclockwise or right. So in other words, the waypoint is some point ahead or behind or whatever relative to the ship, and when we rotate it, it's going to move it through 90 or 180 degrees, not the ship. The ship is still going to point in the same direction. And then forward means to move forward to the waypoint that many number of times. So it's quite different from before. So let's go back and add our tests. So we have this nav position type here, our class here. I think what we probably should have is a new class, a waypoint, and it's going to actually be very similar to nav position. So let's make it a subclass of nav position. Whoops, that was not what I wanted to do. Okay, and because it's a subclass, it already has access to those variables, so we don't need those. And, oops, that makes sense. I wanted this to say waypoint. What they called it? Waypoint, yes. Okay, so that's what I meant to say. Okay, that makes more sense. Now, a waypoint is similar to nav position, but let's go over and write some tests for it. So we've got test nav position. Let's test waypoint. Okay, so waypoint actually is going to need a nav position as well. So we create our nav point, and then we'll create our nav position. We'll create a waypoint, and this is going to be a waypoint new with nav position NP. Because when we move, it's so all the actions on the waypoint don't actually move the ship. It's only when we say forward, and then the waypoint is going to move the ship the appropriate number of times. So now all these NPs should become WPs. W. So except for so all the commands should go to the WP, but all the assertions should be about NP. So let's see, after we've done the F10, what's it say? So F10 moves the waypoint 10 times, a total of 10 units east and 10 units north.
100 units east.
Sorry, 100 units east, 10 units north. Because the waypoint starts out here. So we better add an initialize that's going to set that up. Okay, so let's go over to waypoint, and we'll add an initialize method. Initialize, super initialize, because we want to do the initialization for our superclass. And then we want to we're going to override some of that. We're actually not using the orientation variable. So we could structure this with another class, but I think this is complicated enough. So now we're supposed to start off with north being what? north is supposed to be 1, and east is supposed to be initially 10. Okay. Save that. And, oh no, we do actually still want the orientation the way we have it. So, except that after we've done this F10, this should be north 10, east 100. Okay, so 10 and 100. Okay, and then after we've done the N3 and the F7, we should be at east 170, north 38. So east 170, north 38. Okay. And then after we've done the R90, and the F11, we should be at 214.72. East 214, south 72. Oops, sorry, north should have been minus 72. And east should be 214. Okay, and the Manhattan distance should be 286. Okay, so let's see what we need to do here. Okay, so save that and run test waypoint. Okay, so we created a new waypoint, but we didn't understand nav position, so we'll create in waypoint, and nav position, we'll just set nav position equal to nav position. So we're going to create an instance variable called nav position that keeps track of our nav position. Okay, proceed. Okay, so that didn't work. We got 0 instead of 10. So the NP didn't move, which is not surprising because we haven't done anything to move it. So right now, what's happening is this WP command is running the code in. So what happens is when we send the message to the waypoint object, it doesn't have a command instruction. So it goes up to its superclass, which does have a command. So it's running this code. Okay, so that may be okay because these are the same instructions we're going to have. All we need to do is maybe do slightly different things with these. So maybe we need to override some of these. So let's do the move forward first. So we go back to nav point, and we're going to add a method called move forward. And move forward is going to have a an integer. And now we're going to move that many. We're going to move the nav point by a certain amount. And what we're going to do is we're going to change the, we're going to move north or move east an amount corresponding to our east or west. So we're going to say nav point, nav position, move north. How much? Well, an integer. So let's call it multiplier. because it's a multiplier of how many times we're supposed to do the move. And so we're going to move north, whatever our north is, times the multiplier. Oops, except I didn't spell multiplier properly, so it's not seeing it. Okay. And also tell the nav position. Oh, we can do it as a cascade. Also tell it move east. Our east times multiplier. Okay. Okay, so that's all we have to do is, so what we're doing is we're basically letting the waypoint move the nav position. So let's see if we get further in our test now. So test waypoint, yes, we did quite well. So the north command did the right thing and everything worked fine, except after the rotation, it didn't do the right thing. We got 82 instead of minus 72. So that's not right at all. So what we have to do is we're going to have to change the rotate right method, or override the rotate right method, because the one that's here is not going to do the right thing. Okay, so we'll make a copy of this because we're going to keep the validate. Or actually, let's just call this validate rotation, and we'll just take this code out of here. Okay, so now we'll make rotate right here to a breakpoint. We'll do self validate rotation on the integer, and then we'll do the orientation calculation. Okay, so that's fine. So let's copy the first part of that because we're going to want that in the waypoint. So in waypoint, we're now going to add a similar method. Rotate right. Now, I was doing some calculations earlier to figure this rotation out properly. So let me just grab a little piece of paper that I have. So you can verify this on a piece of graph paper, but if you are rotating something right by a certain number of iterations, we want to transpose and negate the x, or the, in this case, north and east values. But we don't want to do this an arbitrary number of times. We want to do this just so if we do 4 rotations, that puts us back to where we are. And so I'm going to take an integer. So I'm going to put a self halt here, and we'll come and look at the code when we get the trap. So let's go back over and run our test again. Okay, so we're here. We have a waypoint. We have an integer, 90, and we want to rotate right that many times. Well, not 90 times, 90 divided by 90. So we want an integer divided by 90. Well, we could do times do, times repeat. And what this is going to do is just do whatever's in the block that many times. And we're going to have to add another test before we'll see what we have to modify on this as well. But let's just say temp is equal to east. No, is equal to north. Then we want north to be east negated, and east to be temp. And if I've done this right, that should work. So temp is going to be a temporary variable.
Naturally.
And let's proceed and see if we, and it works. Okay, but that's a simple case. If we did turn right or left, we'd have to do something different. So let's add one more test here to capture this, because if we do a WP command, oops, I didn't mean to do that.
What is up with copy and paste today?
I think my keyboard is actually acting up. I've got a really, really nice keyboard, and it's got wonderful, lots of wonderful features, but it's not always doing registering my keys. So I'm going to
Maybe
say
it's a battery issue.
turn left 180 degrees, and then go F11 again, and that should leave north the way it is. Oh no, it won't. Try and make life easier for myself. Let's look at this and see what it says we are. So after we've done this, got 4 east and 10 south. Okay, so if we turn 180 degrees and do F1, then north should be 11 less, so this should become 61, and this should be should be 4 less, so this should be 210 maybe. Let's just try that. Did I get it right? No. Well, actually, I may have gotten it right, but I can't tell that because what happened was that L180 didn't actually do anything. So let's just put a self-halt here, just so that we can run up to this point and proceed. Okay, so now we're going to step over the halt and step into the command L180. Okay, so we'll step over this, we get the number, and then we step over okay, and it's L, so we do this. So let's step over the negated and into the rotate right. Okay, so now let's just see what, I'll step over that. It's been validated. But now what is an integer divided by 90? And it's -2. Well, what times repeat does is this only if you give it a 0 or a negative number, then it doesn't do the loop at all. So what do I want? Well, you might think I want absolute, but no, I don't want absolute because I want to rotate the right number of times. So what I actually need to do is I need to do this mod 4, 4, because if you turn right 4 times, it's as if you didn't move at all. So I want to throw away multiples of 4. And when I do that, what I'll get is, instead of -2, I get +2. So it's going to make 2 steps to the right. Whereas if that was if we came in with a -1, that would become 3 steps to the right. So 1 step to the left is the same as 3 steps to the right. So I believe that I now have the correct value in there. So we'll proceed, and this is -62 instead of -61. Do I believe this? Ah, yes, that's right. It should have been 62. And presumably NP East is 210, yes. Okay, so let's take away the self-halt and proceed, and it works. Okay, so now test day 12A was this. Test day 12B is going to be very similar, except do we have a 12B? Yes, we do. And oh, it should be implemented. Well, that's perfect. But we want it to be just like this, except slightly different. So day 12B is going to be a lot like our test. So we have the nav position and the W position, and we're going to create the WP is waypoint new nav point position NP, and everything will be the same except we want it to be WP that executes the commands, and we still want NP for the Manhattan distance. Okay, so let's go back to our test. Test day 12B, and it looks like it does the right thing, so let's see what happens. Okay, so the first test passed, and the second test says this number. So let's see if that number is the correct one. Save that. Proceed. That's happy. Let's see if this is happy. And it is.
Woo! There we go.
So we got it all straightened out, and our code is a lot better this time around because we now have these separate classes that implement the nav position and the waypoint. So waypoint is just like nav position, except for these. We initialize it differently. We move forward by moving the nav position. This is just to save that, and rotate right. So move forward and rotate right are slightly different. We initialize the nav position as part of the initialization. So let's just this. So this is part of initialization. And did I call these anything? No, I didn't. I should probably call them something. So this is accessing. So classify method as accessing, spelled properly. And north is also going to go under accessing. And then these others, all the moves will, let's just call them classify method, then I'm moving. And so all of these are, actually I'll put all of these under moving. Put Manhattan distance under accessing, and I'll put command in, let's call it control. Controlling. Okay, so that's all good. And now waypoint, we should move. These should be moving. And right, it's also moving. Okay, so they're all classified now. I should probably put class comments, but I think we're good. So now let's go over here and commit this. Commit. And let's see what we've got here. So we've got admin code with 2 new days. We have nav position with a bunch of values. I'm not going to commit these days. Those are just dummy or empty tests anyway, but we'll just leave them out. And we'll take out the data for day 14 because we'll commit those later. And so finished day 12, 2 stars. That was one type start. My fingers know that better than. And why can't I see? Oops.
Stuck.
Okay.
Oh, goodness. Wrestling with Windows on a Mac.
Yes, different kinds of windows, but still. Okay, committing. And done. And now we'll go back here, and it's all good. So let's just go over here and verify that it's all made it to GitHub, and indeed it has. So we're done. So thank you for bearing with us through a redo of day 12.
Yes, thank you. Now we're another day behind.
Yes, now we're more days behind. Yes, there's day 13, 14, and 15 now because it just turned midnight. Okay, take care and hopefully see you tomorrow.
Bye.
Bye.